Can you all hear me? Cool, awesome. Well, it's so good to be back. So yeah, I spoke here last year. That was my first ever conference talk. I absolutely love the sense of community at these ComSum events. And just big thanks to Phil, Joe, all the sponsors for having me. Yeah, I hope you enjoy my talk. So today, I'm going to be speaking about building serverless microservices at Bionic, a tale of code reuse and inner sourcing. So basically what this talk covers is a few of the key microservices we use at Bionic, code sharing through shared packages, code sharing through shared services, and collaboration between our teams using inner sourcing. Quick bit about me, who am I? So I'm a software engineer at Bionic. I'm also a co-organizer of Serverless London meetup, which happens monthly in London. I'm also an AWS community builder, as well as a contributor to the serverless transformation blog, and a maintainer of the SLS test tools testing framework, which lets you test your AWS resources on the real infrastructure. Who are Bionic? So what Bionic does is we are the leading B2B market comparison and contract switching service for a few products, namely energy, insurance, connectivity, which is essentially telecommunications, and finance. And how do we do this? We do this through customer service and through tech. And obviously, I'm a software engineer, I'm a techie, so I'm here to talk to you about tech at Bionic. So tech at Bionic is based on a concept called the Reusable Product Platform, the RPP. What is the RPP? It's essentially a collection of microservices and digital journeys which allow Bionic to help businesses sort their essentials, like connectivity and energy and all the other products I mentioned on the previous slide. The RPP is based on 4 key principles, which are consolidated hosting, event-driven architecture, shared UI components, and common microservices. Everything we do in terms of the RPP is built on a new modern tech stack, fully cloud native. Everything we do uses TypeScript, it's all Node.js, using the CDK, Cloud Development Kit to deploy resources cloud natively. Everything is based on AWS, everything's serverless, and all our journeys are, most recently, we've moved to using Nux 3 for those as well. So very modern approach on the front end as well. I'm going to dive into a few examples of some of the microservices which support our journeys. The first example is the event processor microservice. I won't talk too much about this one now because it's one that I'm going to talk about in a bit of detail later on, but it's essentially the proxy between our digital journeys and the event-driven architecture. But as I said, there'll be a bit more detail about this later. 2 other examples of microservices which support our journeys are the tariff generation microservice. So what this service does is basically creates a personalized tariff or price based on an inquiry made from the product journey. It basically uses a combination of data sources, but also business logic to craft a custom tariff, a custom price for our customers. Another example of a microservice we have is the inquiry data storage service. What this service does is essentially records updates, every single update made to an inquiry throughout a customer's journey on the website, and it keeps a trail of how a price was determined. We think this enhances transparency and trustworthiness, and is really useful to have as an audit trail. There's many other examples of microservices that we use at Bionic. I'm not going to dive into too many more examples because we'd be here all day. But as I said, I'll come back to that example about the event processor a bit later. How do our microservices communicate? We're using EventBridge, using an event bus, event-driven communication. Why do we do this? Well, there's the main sort of benefits you get with an EDA, like fault tolerance, because you can keep a track of all the events that have happened, essentially, so you never lose any information. It's also arguably more scalable because everything's asynchronous, so things can happen at the same time. You don't have to wait for thing A to happen before thing B happens. And the main sort of benefit of why we're using a microservices architecture in general, and it's one of the real big themes of my talk today, is it helps us decouple services and teams from each other. It allows teams a freedom to innovate with few dependencies and few people dependent on them as well. And as I said, we're using EventBridge. The reason we chose EventBridge is that we're essentially fully cloud native on AWS. So it's very convenient that our event bus can be managed and deployed alongside all our other AWS resources. And how do we build at Bionic? So at Bionic, there's 2 main things that we try and do in conjunction with each other. Obviously, we want to deliver quality software across all our journeys iteratively and quickly. And at the same time, we really prioritize maintaining a sense of autonomy for our different technical squads. 2 key components towards these goals, which I'm going to talk about today, are optimizing code reuse, not necessarily maximizing it, and facilitating efficient cross-team collaboration. So let's talk about optimizing code reuse. 3 patterns of code reuse we embrace at Bionic are code duplication, shared packages, and shared services. I could never talk about code reuse and not have a nod to code duplication. So code duplication, copying and pasting, we all do it. Generally, we try to avoid it, but sometimes it is the best option, right? If the frequency of changes are low, it's not something that needs to be changed that often, and isn't something that's reused a lot, and especially if the logic isn't very complex, then that's a strong argument for just copying and pasting and moving on. For example, if we have boilerplate code for, say, an internal service where we want to have another one that's a bit similar, but this is the only use case where we're going to need similar code, that doesn't really create a strong argument for trying to make the code more generic and putting it in a package and so on. Honestly, the suggestion would just be copy and paste and move on. So it's definitely something we do, but obviously the main code reuse topics I'm going to be talking about today are shared services and shared packages. So let's talk about shared packages first. What this is essentially publishing code snippets in a private GitHub or NPM package, which can be imported and used across multiple repositories. So as you can see sort of visually over here, you have code snippet 1, C1, code snippet 2, code snippet 3, and services A to E are able to only use the code snippets that they want to use. So quite a neat solution, and no copying and pasting needed. How do we, I like going into a bit of implementation detail here, so how do we publish shared packages? Essentially, you make the code change, so any code change to a shared component or a shared construct. We like to test locally using npm link, so we always have a sort of dummy project going on that will just use all our constructs or components just so we can test that things work before actually creating a release for the package. You create the PR. Once it's approved, you of course merge it. And then we have a custom GitHub action which runs as part of a GitHub Actions workflow, which builds the package, it updates the version for us, and it publishes it. How do we use the shared package? Well, this is even simpler than the last slide, really. It's essentially like the same way you'd use any package, but it's got 1 or 2 steps right at the start. As I said, we're dealing with private GitHub packages here, so you need to generate what's called a GitHub PAT, personal access token, pardon. It needs to have the read packages permission. That's the only permission you need. You just need to be able to read them. You don't need to be able to change them. And once you've generated that token, you need to update your .npm-rc file. You can either use the npm login command for this, or you can just honestly just copy and paste the PAT straight into the .npm-rc file. But either way, once that file's updated, you run npm-i, package name, and you continue as normal, like you would with any other npm or GitHub package. Why do we use shared packages? We find it helps us improve consistency across our repositories and our visual journeys. It also increases delivery speed because individually, you're not having individual teams all trying to solve the same problem. You can just take a code snippet from somewhere where another team's already solved the problem for you. And also, it allows us to bake in best practices. But I'll dive into an example of how we do that now. Quick show of hands, who uses CDK? Okay, I'd say maybe about 1/3 of the room. That's perfect. Cool, well, I'm going to give you a little intro to CDK here before I dive into detail. So what is CDK? It's essentially a form of IAC, infrastructure as code, and it uses common programming languages that a lot of us, I'm sure, are familiar with, like TypeScript, Python, Java, and so on. And basically, like any IAC, it allows you to create AWS infrastructure, and in this case, it's by instantiating classes in code. So in TypeScript or Java, that would be using the new keyword. Why do we use AWS CDK? Well, the fact that it's object-oriented means developers are able to build on existing knowledge. The object-oriented paradigm is one that a lot of us are familiar with, either from university or from just learning programming in general. So we find that's really helpful. And also, it uses well-known languages. So again, that's less of a learning curve. You're not having devs need to learn how to write declarative code or declarative infrastructure documents using things like YAML and JSON. They can just use languages that they're familiar with, which we think speeds up learning how to write IAC a lot quicker. So the example I'm diving into regarding shared packages is we have a package at Bionic which we use containing shared custom CDK constructs. I'll talk quickly about the anatomy of a CDK app. So any CDK application is made up of one or multiple CDK stacks. You might be familiar with CloudFormation stacks, And every stack is made up of one or many constructs. And what a construct is essentially a representation of one or many AWS resources. The way you deploy a CDK app is, once you're ready to deploy, that application code, that code in a familiar language that we're all familiar with, is essentially, like Java or so on, is synthesized into a CloudFormation template, which is then uploaded to AWS, and all the resources are spun up for us. Constructs, this notion of a construct allows for 3 layers of abstraction. The first layer is called an L1 construct. What an L1 construct is essentially a direct mapping to a CloudFormation resource. So all these constructs, they all start with CFN. So in this code example here, we have CFN bucket, which is essentially the L1 construct for creating an S3 bucket. These constructs are essentially just a different language, but it's just a different way to define CloudFormation resources as you would in something like YAML or JSON. The next level of abstraction is called an L2 construct. So what this does is, these constructs essentially, they're the same, but they include a little bit of boilerplate code, they set some defaults automatically, and conveniently, they provide some functionality on the class. So for example, here, we're creating this exact same S3 bucket as before, but this S3 bucket has versioning enabled, and it's something that we're able to do very easily by passing in the version prop as true. That's not something you'd be able to do as simply with an L1 construct. The next level of abstraction, this is a sort of intermediate level. This is called L2+. So all L2 constructs are released by AWS. L2+ is where we come in and start writing our own custom constructs. And what they allow us to do is bake in best practices and enforce standards across a code base. So these constructs, L2+, they strictly only represent one AWS resource. So it might be a database or a Lambda function or an S3 bucket. And it allows us to enforce characteristics specific to our code base. So for example, this is a code example here. I think I used this one last year as well, actually, because it illustrates it very well. This is a Lambda function which only works for specific node versions. So what we've done is we've extended the Node.js function class, which is an L2 construct from AWS. And we've got a bit of logic in there to say, if the person instantiating this construct has passed in a runtime for the Lambda function, then if it is Node.js 16, awesome, we'll deploy it. If it's not Node.js 16, you can throw a custom error and say, sorry, but all Lambda functions at Bionic have to be Node.js 16. This is, of course, just a theoretical example. And then what we've also done at the bottom there is set it so that if the runtime is not passed in, then by default, the Lambda function will use Node.js 16. What the next level of abstraction allows us to do is take that concept, but apply it to multiple different resources. So through object-oriented programming, we can create custom classes which, when instantiated, will spin up multiple AWS resources. So for example, we have a construct at Bionic, which when instantiated creates a Lambda function. It puts an API gateway endpoint in front of it. It pre-configures it with a web application firewall. And also, it even will create a CloudWatch dashboard widget for you and set up some alarms. And this saves us a lot of time when spinning up a new serverless API, which, being in a serverless paradigm, we do quite frequently. Quick note, I definitely recommend checking out AWS CDK patterns. It's a great database full of L2 and L3 constructs, which are pretty much good to go out the box. So I definitely recommend checking it out. It can save you a lot of time. So what are the possible pitfalls with shared packages? I've shown you how it can save us time by abstracting over multiple resources, allowing you to spin things up quickly. Last year, I was actually not in this room, but in another room at this exact conference, and I saw Bob Gregory from Kazoo, he was at Kazoo at the time, use this very good example, and I'm going to use it right now, so shout out to Bob. But imagine you have a front end and an API. They are loosely coupled through shared schemas for the request and response. And someone says, oh, cool, well, why don't we take those schemas, make them TypeScript interfaces, and export them to a package, either GitHub or NPM. But what you've just done now is you've taken two pieces of code, which are loosely coupled, and created a much stronger coupling. Now they're coupled at build time, and every single time you want to make a change to a schema, you're also going to need to make a change to this package. It means it's just another PR which needs to be reviewed. And I suppose the moral of the story here is make sure you're speeding up development, not slowing it down, because this is sort of an unnecessary dependency. So definitely watch out for that when adopting shared packages in your orgs. The next pattern I'm going to talk about is shared services. So I'm sure a lot of us are familiar with this concept, but what it is just deploying a single instance of an application which is used by other applications. So in this example here, we can see code snippets 1, 2, and 3 are all existing in the shared service. a single instance of the shared service which is deployed, and it's being used by services A to E. None of the code exists in the source code of services A to E. I'm going to dive back into our event processor example from earlier. So what the event processor is, I said it's a proxy between our journeys and our event-driven architecture. It essentially performs the following steps. It consumes API requests from the front end using API gateway. It's then got an AWS Lambda function, and what that does is it maps these requests to their relevant event schemas, and it then performs schema validation on them using Zod, which is a great library for schema validation. And then, once the schema validation has happened, and we're happy that we have everything we need to have the event, we then publish it to our event bus, which, as I said earlier, we're using EventBridge for. And I suppose on this slide, you might be thinking, you haven't said anything about it being shared. You've explained what the service does. And the question is, why not have an event processor for every journey? Why have it shared between our insurance journey, our energy journey? Why not follow more of a backends for frontends approach, right? And have an insurance event processor and an energy event processor. So yeah, why did we opt for a single event processor? Well, one, it's easier to enforce that the same standards are being met, so the same level of schema validation. It's also less code to maintain. And even if it was the same code and you just deployed multiple instances, it's less cloud resources to manage as well. It's a single Lambda function. Also, there's the same benefit that any change which needs to be made across products only needs to be made in one place, which is very convenient. Similar to that, it's a single source of truth for our event schemas. So what we do is we're following the single writer principle, which essentially means all the events being emitted by the event processor are only emitted via the event processor. So if there's ever a problem with the schema, or you see an event which doesn't match the schema, you know that that event didn't come from the event processor. Finally, any code change you're making to a shared service is going to possibly be impacting other teams. So it definitely encourages effort to make sure your tests are robust and you're not breaking things. So it sounds like a neat solution. What are the disadvantages? What are the risks with a shared service? Shared services can look like that. They can get really, really complex. If you have multiple different consumers, which slowly but surely have more and more diverse requirements, you're going to need more complex solutions. And with all that complexity existing in one place, it can get quite messy. And I suppose what you don't want to do is let what was once a microservice become just multiple backends for frontends all in the same application, because then it's no longer really a microservice. For example, if Bionic decided we were now going to, along with insurance and energy and all the other products we support, we're going to provide market comparison and switching for a new product, a hypothetical, very complex product that required a lot of transformation to happen just to even be able to build out the events to be able for them to work in our system. That would be a strong argument for that product having its own event processor, because you've got all this complexity you're about to introduce. You don't want to tarnish your nice, clean, simple service with all that complexity. So we need to be pragmatic and not essentially just, the shared services, it's not a blanket solution. Please don't just do it for everything, because in this case, we'll definitely be spinning up our own complex product event processor. And yeah, this is another thing that I'm going to be talking about is in this paradigm with the shared services, the shared packages, how do we build? And how do multiple teams work on these products? So there's two key practices I'm talking about today, which we use at Bionic. One is called inner sourcing. What this is essentially open source, but within a company or an organization in our case. And the second thing is the weak ownership model. And what this is where it's a model where services and packages have owners, but developers are allowed to change code which is owned by other people. So let me quickly illustrate how inner sourcing works in practice. So say you have team A, in team A exists person A, they require a change to be made in a service or package which is owned by team B. Instead of asking team B to make the change, person A can just make the change themselves. They write the automated tests, they create a PR in the repository, because it's the same tech stack after all our services, all our packages, they're all using the same RPP tech stack. And all team B has to do is review the PR and eventually approve it. So what happened there? Person A, they didn't have to wait for team B to have the capacity to make the contribution themselves. And team B didn't need to create the ticket and refine it and prioritize it and bring it into a sprint. All that, and also this ticket would have been kind of unrelated to team B's goals potentially. All they had to do was review the code. So it's much less of a dependency there. And the sort of going line is, we favor pull requests over feature requests. And that's all around. The same thing that works in reverse here. Team B, if Team B requires a change in something done by Team A might say, oh, well, we're busy making a change in one of your repositories, why don't you make the change in ours? And given that it's the same tech stack, they're able to do it quite quickly. And inner sourcing is growing in popularity. So according to GitHub, companies like PayPal, Bloomberg, and Walmart have been using inner sourcing to build software for their teams and their customers. And yeah, they say it provides them with a unique competitive advantage and helps them stay relevant by adopting recognized best practices. And these are some big names, so it might be worth checking out. But and before I suppose tell you what the catch is, what are the benefits of inner sourcing? Well, as I just illustrated with that example, it minimizes inter-team dependencies. It allows teams to drive innovation with minimized bottlenecks because you're never waiting on another team to prioritize a ticket for you. Also, multiple teams working on shared code bases leads to a sense of collective responsibility for the platform's success. And also, it gives teams ownership over their contributions. They might have a requirement, they're able to fulfill that requirement as well themselves, which is very empowering. Quickly before I move on, that's the logo for Inner Source Commons. It's the world's largest community of inner sourcing practitioners. So if you are interested in learning about more inner sourcing and learning about what other teams are doing, other companies are doing, definitely I'd recommend checking it out. But inner sourcing combined with the weak ownership model, you have multiple owners, collective responsibility for everything. What could go wrong? And I'm sure we've heard the phrase, if everyone's an owner, no one's an owner. So this is definitely something we've had to refine. And people have also called the weak ownership model the no ownership model, which is not really what it is. But typically, the de facto weak owners of a service are the historically most active contributors. So people whose GitHubs look like that. But what happens when these engineers leave or maintenance for the service slows down because of no real new requirements and the code isn't touched for a while? The solution is we need to ensure that owners are assigned. So weak ownership, yes, but still owners. So in practice, PRs are welcome and encouraged from anyone, but PRs still have to be approved by owners. Owners are the ones who are accountable for service availability and standards being met, QA testing, and so on. Also, the overall vision for the RPP, given that it's sort of a collective movement across our org, it's maintained by a separate working group called the RPP committee in our case. It's led by the architects and the tech leads. But, most importantly, anyone can join. And what this does is, this avoids fear of gatekeeping and allows for more cross-team collaboration because everyone feels included. And the conclusion is essentially what you need to do, and what I think we're trying to do, and I think we've done to some extent, is find the right balance. You have to take a pragmatic approach to code reuse and find the right balance between code duplication, code sharing at runtime, shared services, and code sharing at dev time, which is shared packages. And of course, I'd highly recommend experimenting with inner sourcing and the weak ownership model, because we found it to be quite useful, but be aware of the trade-offs in doing so. I'd love for you guys to connect with me on LinkedIn. If any of you have experimented with any of this before, I'd love to know more about what's happening in your orgs. And so please do reach out to me on LinkedIn, or you can find any of us around the room. We're all in our Bionic t-shirts today. And thanks so much for having me.
Awesome. Thank you very much, Joel. Okay, so it's a full room. I'm sure there are lots of questions. Who wants to kick us off? Great. Morning, Tim.
Hello. I apologise that this might be a longer question than your answer, but I'll try and set some context. So it's about how to decide whether to make a shared code component or a shared microservice. I'm interested if you've got some advice, make some stories. Maybe someone got this wrong and you've got a story about that. So tell us more about when shouldn't you build left-tab.services.bionic.uk and that should be a library, the other way around.
It's a really good question. So, of course, as you can imagine, there's a variety of factors. One main factor that we strongly consider is essentially frequency of code changes. If we think that it's something which is going to change a lot and adapt a lot, then we think, okay, this isn't ideal for a service because it isn't ideal for a package because we're going to have a million different versions, and it's going to be confusing to know which consumers of which package are on what version. I can't think of any examples off the top of my head where we've gotten it wrong, because there's always a bit of thought happening before. Obviously, when it comes to things like front end, that's sort of a no-brainer. Shared components have to be in their own package. You can't really have a service for fetching components or something like that. I think that's it really. I mean, the frequency of code changes is definitely the big one. And I guess another one that we consider is how many people are going to be using it. So if it seems like we're going to have an absolute ton of people using this, like a ton of different teams or different consumer repositories, and their requirements are quite diverse, then that almost favors either a non-shared services approach, like a specific service for each, or a package, right, which has similar functions or similar functionality provided for the different products, but it all still exists in one place, meaning you still get that benefit of when you need to make a change across all products, it only needs to be made in one place. So those are just a few of the factors we'd consider, but there's a whole lot more as well.
Happy with that? Want to grill it some more? So you are, interestingly, the lucky winner of a Bionic t-shirt for asking the first question. You got more t-shirt? That's the only one. So, anybody got any other questions?
Joe, thanks for the insights. So, I get the shared ownership, share. I'm not a fan of shared ownership of microservices, but my question is, core ownership wise fine, but who owns the deployed operating services in the cloud?
Yeah, that's a good question. So that's owned by the assigned owners, essentially. So I'm not going to be, for any specific service, basically. So say Team A owns the event processor. They'll be responsible for all of that, deployment, all of it. All Team B does, or anyone from Team B who wants to change, the service owned by Team A, they just create the PR. So, there's that little bit of overhead, of course, of managing a service when a change gets made. But we find it's still beneficial and it's still less work, essentially, than if they had to wait and make the change themselves.
Do you operate multiple accounts, or they're all in the same?
In the same account?
Yeah, AWS cloud account.
Yeah, so we're not really at the stage yet where we need anything like account per service or anything like that. We essentially have accounts for our different environments. So, dev, staging, prod. We have a sort of playground account as well for learning purposes. But I think as we scale, there might be the argument made that account per service is the best strategy.
Good stuff. Other questions?
Hi, so my question kind of, relates to ownership. Expand on your event processor. So you mentioned that an event processor is a single right for your event bridge and your event bus. Do you apply the sort of weak ownership principle when changes being made to that bus itself in order for rules and configuration to actually, proliferate those events further?
It's a really good question. So I suppose the rules for the event bus themselves they fall within the domain of the consumer. It's not really a consumer, but yeah, kind of the consumer repository. So if I create the Joel Hamilton service and I want to consume specific events from the event bus, I'll create a rule, and essentially that's owned by the owners of my service. It's not, we don't have a sort of DevOps team who manage things like those shared resources, like the event bus, or like even shared tables. They sort of just fall within the domain of the services which are using them. Yeah.
Yes, there's like a handoff from when the event's written to whoever wants to put the consumer in there, deploy the consumer resource or rules.
Pretty much so. And the bus itself, the configuration never really changes. It's more just rules. And that, you can create your own CDK app entirely. As long as it's in the same account, you can use from event bus on, pass in the on, and essentially you now have access to the event bus and you're able to create rules, provided that you're in the same account and have the permissions, of course. No problem.
Okay, I think a couple more minutes.
Yeah, definitely.
Another question? Yep.
Hi. You talked about having named but weak ownership, and they review the PRs from other teams. How do you stop gatekeeping in that scenario where the named owner may become a gatekeeper? Have you got any tips for how to handle PRs?
Yeah, it's a good question. I think when you know that the owner of a service is a different team, you already feel like a bit of an outsider, right? It's not. I don't really consider it gatekeeping if all the services or if all the owners are trying to do is they want to make sure that a change belongs in the right place, that the change should be made in their service and not elsewhere, and that the change is sort of aligned with the same repository structure and meets the correct standards and has sufficient testing. I don't think people consider that gatekeeping, but I guess that encouragement of encouraging pull requests over feature requests is hopefully enough to prove that we really do want you to come and make changes in our service. We're not trying to keep you out. And hopefully that doesn't put people off wanting to make PRs in other repositories. Because the alternative is waiting weeks for it to be prioritized and pulled into a sprint and so on. Hopefully that answers your question.
Yeah, thank you.
Awesome.
Okay, I've realised actually you've left plenty of time for questions. So, here we go. Yeah, I was just wondering, how did you manage knowledge transfer of your source library repository? So you've got some new joins and you are a massive organisation. How would an individual developer know that something they're about to do already exists? And obviously, how do you manage that? Because everyone can't know everything. I'm just wondering tips on that one.
Absolutely, yeah. It's a good one. I think we really prioritize our documentation. So we have a source of truth, which for us is Confluence, but it could be anything, it could be Notion. And that we have a catalog, essentially, of all our shared services and our shared packages. But also, I think our tech org is possibly quite small enough that even if you are new and you might not know, someone in your team will know, hey, I think I know someone solved that problem, and there's actually a function or a construct which will solve that problem for us. But as we grow and as we scale, I think keeping that catalog up to date will be a key factor in ensuring that we don't, there's no duplicated efforts, multiple teams all trying to solve the same problem, essentially.
Does it, so I'm going to say pretty much that text code itself, or is there any examples where somebody has to do something and then it's get out and it's already got that? Or is that just not really an issue?
It hasn't happened. I've seen the example where people have almost from first principles created a certain bit of configuration with AWS infrastructure and then having someone else say, oh, that seems like a really good use case for a shared construct. Can you make a generic and turn it into a shared construct? But I haven't yet seen the example, and I mean, maybe it's happened, just not in my squad, right? But where someone's solved the problem, spent days on it, and then said, here you go, guys, I've solved the problem. And someone's been like, oh, you should have just used this package and would have solved the problem for you. Because I think the knowledge sharing is good enough. Also, I think, how I alluded to the working group we have to manage sort of ownership. It's called the RPP committee. That has representation from all the teams. So really, people should be aware of what's out there at the moment, within the tech org.
Cool. That sounds really good.
Awesome. Thanks.
Great. John, could I ask you to move into camera shot?
Oh, sure. I didn't realize. So sorry.
You very recently wandered off shots.
Okay, good.
Got to think about the video.
Yeah, fair enough.
Thank you very much for talking. It's been really insightful.
Thank you.
I guess the question for me is when somebody makes a change or an update to a shared service or a package, what does the process look like for propagating that change, communicating or updating? Yeah,
that's a really good question. So we have a shared Slack channel. So, and again, that's RPP committee, but it's welcome for anyone. And we will say, hey all, release has just come out. It's a patch, so get to it when you can. and we'll say which package it is and so on. And given that there's representation from all teams on the channel, they should be able to see and be like, okay, cool, noted. Next time we make a PR, we'll just update that version for us. But we also use Dependabot as well, which is a bot on GitHub, which will automatically detect there's been a change in a dependency. So if someone misses a message on the Slack channel or something, they'll get pinged by the Dependabot that night or the next night or something, and they'll know then to make the change. And shared services, because obviously that's not something Dependabot will check. There we're slightly more reliant on the Slack channel approach. But again, unless it's a breaking change, it's not really something you need to stress about. But of course, knowing that a service is changing that's being used by your team, you're always going to want to go and just check out the PR and just make sure, as a sanity check, that nothing you have is going to be broken.
Can you talk to me a little bit more about that process for breaking changes in services?
Yeah, honestly, if there's ever going to be a breaking change in a service, by the time the change is made, everyone knows about it, essentially. If you want to go and make a change in a service that doesn't break anything, you can just go ahead, create the PR, get a few approvals, and that's it, from whoever owns it. But if there's a shared service and you are talking about an actual refactor or something that'll break something, everyone, at least one person from every team, at least the tech leads, will know about it and be prepared for